Dr. Quinn encourages learners to use other sources beyond what is available through his course. He is here just to provide you with yet another explanation.
Yet another explanation of the measure's essential tendency. We begin with the mean. The mean describes the average or typical response of a variable's distribution. The mean can be used to describe continuous variables. The mean is also heavily influenced by outliers or extreme values. On the right, you see the formula for the mean. In the numerator, you have the summation of x, which means that you sum up all the values in a variable's distribution. And in the denominator, you have n, which represents the total number of values. This formula computes the mean, or as it is often represented, x with a bar over it. By definition, the mean is considered the typical response. Yet the mean can sometimes be misleading because of extreme values of x. Let me show you what I'm talking about. In this example, we have data describing the number of years it took 10 people to complete their doctoral degrees. We compute the mean by summing up all the values, giving us a total of 39. Then we divide 39 by 10, or the number of data points we had, resulting in 3.9 years. So we now have a sense that the average time it takes to complete a doctoral degree is 3.9 years, or 4 if we're rounding. Now let's look at a similar situation, but this time we are going to replace two of our numbers with the extreme values of 15 and 13. As before, we sum up all 10 values, and this time we get 59. We divide that by 10 to get a mean of 5.9. The two extreme values increase the average time it takes to get a doctoral degree by 2 years. However, examining the raw data, it still seems like most finished in 3 or 4 years, not 6 as reported by the mean. Next up is the median. The median is a statistic that describes the middle number in a variable's distribution, or the number that occurs at the 50th percentile. Like the mean, the median is used with continuous variables. Let's return to our group of 10 doctoral students, 2 of them who took a very long time to finish their doctoral degrees. To demonstrate how to find the median, we first rank order our data from the lowest value to the highest. Next, we find the location of the median using the formula you see here. You take the number of data points you have, which in our case is 10. You add 1, that gives us 11. Then you divide your numerator by 2, giving us 5.5. 5.5 represents the location of the median, not the median itself. So we would use 5.5 to find the location of the median. But first, if the number of data points, or n, is even, you average the numbers that are above and below the location. If the number of data points, or n, is odd, then the median is the value at the location indicated by the formula. Returning to our data, we use the formula and see that the location of the median is 5.5, or between the 5th and 6th value in our rank ordered data. In our example, the number 4 happens to be at both the 5th and 6th spot. Given that our n is even, we add 4 plus 4 and divide by 2, resulting in our median of 4. Notice that the median provided a value more reflective of the number of years it took. This is because, unlike the median is not influenced by outliers. The final measure of central tendency is the mode, or the most occurring number in a variable's distribution of data. The mode can be used to describe both categorical and continuous variables. A variable that has one mode is called unimodal. A variable that has 2 modes is called bimodal. And a variable with 3 or more modes is called multimodal. So putting this all together, you see that the location of the mean, median, and mode in a variable's distribution has profound effects on the symmetrical properties of a distribution. When data is symmetrical or normally distributed, the mean, median, and mode are roughly the same. When the median and mode are greater than the mean, the distribution becomes negatively skewed. In a situation where the median and mode are less than the mean, the distribution becomes positively skewed. But let's save any further discussions about the distribution of data for another episode. And that, my fellow learners, is yet another explanation of measures of central tendencies.
Join us next time for another exciting episode of yet another explanation.